Hello children, we all are discussing chapter number 13, magnetic effect of electric current from last few days, and we have discussed some of the very important topics from this chapter. We're going to move ahead with the same chapter and with a new topic. But before that, you all can recollect and remember that in the last video lesson, we have learnt about a current carrying conductor when placed in a strong magnetic field experiences a force. So it was Andre Marie Ampere who suggested that if we place a current carrying conductor in a strong magnetic field in such a manner that it is not parallel to the magnetic field, then this current carrying conductor, it experiences a force. We also studied that the direction of the force experienced by the conductor depends upon the direction of the electric current, and it also depends upon the direction of the magnetic field. We also discussed that the direction of force of the current carrying conductor in the magnetic field is given by Fleming's left-hand rule. This Fleming's left-hand rule states that if we stretch the three fingers of our left hand, the three fingers are the index finger, the middle finger and the thumb. If we stretch these three fingers in such a manner that they are mutually perpendicular to each other, and if the index finger is in the direction of magnetic field and the middle finger is in the direction of the flow of electric current, then the thumb will give us the direction of the force experienced by the current carrying conductor. Based on this concept, children, we are going to learn a new thing in today's video lesson. But before we go ahead and before I tell you what is the new topic of today's video lesson, I would like all of you to have a look at some of the pictures which are flashing on the screen. You all have many toys at home which rotates. The moment the battery is on, these toys, they move, they rotate, they move from one place to another place. Also, the common example is washing machine. The moment we, put the button on, the washing machine starts rotating. The tumbler of the washing machine, it rotates inside, isn't it? We have mixer, grinder, juicers at home. The moment you put the button on, mixers, grinders, they start rotating. The blades of the mixer, the grinder, the juicer, they start rotating and we can extract the juice from the fruits. In case of a mixer and grinder, we can get, fine thing of the material which is put into the mixer. You all have seen a water pump. It is used to take out the water from the ground and then we can water the farm. And a very, very common example is the table fan and the ceiling fan. The moment you switch on the button, the fan starts rotating. Now, what is there common in all the pictures which I have shown you? What is common in all the electrical appliances which I have shown you? The common thing present in all the electrical appliances which is making it to rotate is electric motor. And this is what is the subject of today's video lesson. So children, electric motor is a rotating device. It is a device which rotates or moves round and round. So all the electrical appliances which I showed you in the previous slide, in all electrical appliances, electric motor is present. And this electric motor, it converts electrical energy into mechanical energy. Let me show you the picture of electric motor. Can you just identify this? Can you just, recollect that you have used it somewhere? Yes, children, during our science exhibition, you all have used a small DC motor. You remember that? And a very common example is windmill. All have done this experiment. You all have made a model of windmill, wherein you used to rotate the fans of the windmill with the help of a small DC motor. That is what we are going to learn today. All right. So what is the principle of electric motor? An electric motor works on the principle that when a rectangular coil is placed in a magnetic field and the current is passed through it, a force acts on the coil and the coil starts rotating. So this is exactly what we learned in the previous video lesson. A current carrying conductor experiences a force when it is placed in a strong magnetic field. Alright, so if we are asked about on which principle the electric motor works, it works on the principle that a current carrying conductor, when placed in a strong magnetic field, it experiences a force. Alright, let's understand what are the parts of electric motors and how does it look like. It means we're going to understand the construction of electric motor. So look here, it consists of two very strong magnets. One acts as a north pole and the other magnet acts as a south pole. These two magnets, they produce a very strong magnetic field between them. And in that magnetic field, a rectangular coil ABCD is placed. This rectangular coil is also called as an armature. So in the strong magnetic field of two horseshoe magnet, a rectangular coil is placed and that coil is called as an armature. Now if you look at the two ends of this armature, you can see that towards the two ends, two rings, split rings are attached. A ring which is splitted into two parts. Can you see that? And that is the reason these are also called as split rings. These two rings are attached to the two ends of the armature coil. These split rings are also called as commutator. Now when we will learn about the working of electric motor, you will understand that the commutators are used to reverse the flow of electric current in an electric motor. Now these two black color things which you observe, these two are called as carbon brushes. These carbon brushes are placed just on the upper side of the split ring or on the upper side of the commutator. And to this carbon brushes, we will attach our circuit, which consists of a battery and a plug key. So this is how the electric motor looks like. Alright children, the lower assembly, that is the carbon brushes, the battery and a plug key, it is a fixed circuit. Alright, these split rings or the commutators, these are not attached to the carbon brushes. They are just pressing against the carbon brushes. They are free to rotate. Carbon brushes are not fixed with the commutators. Alright, so when we will learn about the working of electric motor, that time you will understand this in a very good way. Time being, just keep in mind that the carbon brushes are not fixed with the split rings. The split rings are just pressing the carbon brushes. Carbon is good conductor of electricity. So when we will pass electric current through the circuit which we have attached to the electric motor, the electric current will pass through carbon brushes, and through carbon brushes it will enter into the split ring, and through the split ring it will enter into the rectangular coil. So the moment we plug in the key, the electric current will start flowing through the circuit in this manner. It will first pass through the side AB of the rectangular coil and it will come out from side CD, and this way the circuit gets completed. Look at this rectangular coil once again children. Alright, and I'll show you one more thing. This is what is the direction of the magnetic field. That is from North Pole to the South Pole. And the reason why have we taken a rectangular coil and not a circular coil or not a triangular coil or not a very other shaped coil? It's because this rectangular coil, when placed in a magnetic field, you will observe that it is perpendicular to the magnetic field. And I told you that when a current carrying conductor is perpendicular to the magnetic field, it experiences maximum force. Alright, so I want everybody to keep in mind all the parts of the electric motor, because we will keep taking the names of armature, commutator each and every time when we will discuss about the working of electric motor. So this is all about the construction and the different parts of electric motor. Here we can see the points which you have to write when you are asked about write the construction of electric motor. So you will write that a rectangular coil of wire ABCD is placed between the two strong magnets, and these two strong magnets, it produces a very strong magnetic field. A coil is placed perpendicular to the magnet, like how I showed you. The ends of the coil are connected to the split rings. The split rings act as a commutator which reverses the current in the circuit. The inner side of the split ring is insulated and it is attached to the axle which is free to rotate. Axle is used to rotate the coil. Alright. Then the external conducting edges of the split ring, it has two carbon brushes which are attached to it. These carbon brushes are attached to the battery to complete the circuit. So this is how stepwise you have to write the construction of each and every part of the electric motor. Alright, so I want all of you to go through all the parts once again and recollect what all we have used. In the next video lesson, we will learn about the working of electric motor. So till then, please revise and see all the slides once again carefully. Bye and take care.